My hater? Oh. No, he haven't commented for a while. I was surprised. I was gonna comment to him. You haven't leave any comment.
I like the border.
Huh? Oh. Wait, why is that mic?
That's low-key fire.
I'm a professional streamer. All right. Any question, chat? What? I know. Give you double today. All right. So we were talking about power rule, but I did forget about talking about something. So I'm gonna go back and talk about something that's very, 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 very important. It's called differentiability. So I come up with this idea, like, if you see any other AP teacher is for me. But I draw a pyramid, and this pyramid is very important for this class. You can color code them if you want to. The bottom of pyramid is gonna be the bottom of pyramid is very, very essential. So I here just limit exists. So limit exists happen with definition wise. It's gonna be limits as x approached a from the left of f of x is equal to limits as x approached a from the positive side f of x. Now, in terms of graphing, it's going to look like something like this. It's going to be like this. Limit exists. From left and right, we the rich equal to the same value. So that's in terms of graphing. So that's going to look like that. Now you're blind?
Yeah. Forgot to be born, I can't see.
You need to change your prescription.
My eyes changed. Unfortunately.
On the bottom says limit exists. On the bottom there is limit x approach to a from the left of f of x equal to limit x approach to a from the right. So here is the second layer. Second layer is continuous. So if something continuous must fulfill 3 requirements. We did that on the last test. What are those 3 requirements? First is what?
FA must be defined.
A must be defined. So FA is defined. What would they look like in terms of graph?
A point.
But just a solid dot, right? We did that. The second condition says limits as x approach to a of f of x exists, which is the prior thing. So it will look like something like this, right? So in this case, I have fulfilled 2 conditions. But is this function continuous?
No.
No. So what is the third condition?
Limit x approaches a of f of x equals f of a.
Limit x approach a of f of x is equal to f of a. Good. So then I can move this and move up to fulfill here. And that becomes the continuous. Now imagine if this is a roller coaster, right? Imagine this is a roller coaster like this. And imagine if I draw a roller coaster here. Would you want to ride this roller coaster? No, right? And would you want to ride this roller coaster?
Yeah.
I mean, it'll be quite fun. I don't think you'll be alive, but yeah, it's gonna fly out a track. And that's not something you want to ride on. Unless you're in unless you're in my favorite cartoon, Phineas and Ferb, then that might work, right? I love Phineas and Ferb, by the way. It's full of creativity.
Can I see what?
So I call it connected roller coaster. So I call this as a broken roller coaster. So this is broken. So this is analogy. So broken roller coaster. And this is connected roller coaster, but this is just analogy. Please don't say on the AP exam. So this is a connected roller coaster, but we really need a functional roller coaster. So what's functional roller coaster? That comes down to differentiable. So differentiable, what does differentiable mean? Differentiable means slope from left equal to slope from right. Slope from the left equal to slope from the right. What would be notation look like? Limit as x approach a from the left of f prime of x rather than f of x is equal to limit x approach to right of f prime of x. And yeah, so slope from the left equal to slope from the right. What would that roller coaster look like? Hope it looks like something like this, right? Any part of this graph, the slope is gonna from left to right. So for example, that if I draw a tangent here, if I draw a tangent here, basically they are just completely smooth. Okay, another thing is like it's very smooth. Really, really smooth. Okay, so that's differentiable. Now here's the thing. Why did I use pyramid? Because pyramid kind of apply for a lot of things. If I say this function is differentiable, what does that mean?
It's also like continuously exists.
Yes, exactly. It's also continuous, it also exists. But if I say its function is continuous, does that mean it's differentiable? Because they are the bottom of the pyramid, it's not including the top. I don't have to build the top. They could be, but not necessary. But a lot of time you're looking at AP exam is always true statements, always true. So you cannot say, oh, it could be, it's not a true statement. Is it possible it's not a true statement, right? It has to be. So if I say the function is differentiable, what it has to be is it has to be continuous. FA must define, limit x approach to A must exist, and limit x approach to A must equal to fx must equal to FA. So it must have all those three conditions. But if I just say the function is continuous, then it does not mean it's differentiable. That's the thing. On AP exam, love to play with the words, and you have to understand the words. And the pyramid scheme, it will really help you to figure out like what it's supposed to be. Okay? So is that okay? This is something that's super, super, super important. With that being said, we're gonna go to talk about when it's not differentiable. So when the function is not differentiable, at first, when function is not continuous. How many situations when they are not continuous? When you have a hole, right? When you have a vertical asymptote, right? Those are not continuous, right? What would be the second situation is not continuous, not differentiable? Well, slope on the left is not equal to slope on the right. The best easy way to analyze is called sharp turn. But please don't write that on AP exam as well. Sharp turn does not define on AP exam. You have to say limit x approach to the left of f prime of x does not equal to limit x approach to the right. So in this way, it's going to be better. F prime of x does not equal to limits x approach to right of f prime of x. The perfect example are absolute value x or x to the 2 over third. So what is 2 over third? This is also known as the even over odd power. Even over odd power is something happened on the graph. We give a special name called a cusp. A cusp doesn't always happen, but only when it's something to the even over odd power. It's gonna form a cusp. Last one, third condition is kind of special because it works on roller coaster, but it doesn't work with differentiable. This one is called vertical tangent. Or slope is equal to infinity. That's just also another way to see vertical tangent. Vertical tangent is actually one of the situation. Now you're gonna say, okay, well, what does sharp turn look like? Well, sharp turn and vertical tangent sometimes can overlap. In this case, a cusp is kind of between vertical tangent and sharp turn. So cusp is for both. It has sharp turn and vertical tangent at the same time. And you're gonna be like, what's cusp look like? Well, the cusp look like this. X to the 2 third power. Oops. This is called cusp. Imagine this is a roller coaster, right? You don't want to die this way. At least where the cusp is, it just kind of and it's blow up. So you don't want to ride a roller coaster this way because you'll never build a roller coaster this way. Now, I had one student ask a girl out a long time ago. Yeah. Seriously, I did. So he built this equation. He asked the girls, would you be my Valentine? It worked. In a nerdy way, but it worked. If you look up on here, it's actually even more impressive. But here is just a different way. Now you see that x to the 2 third. This is the top part of the heart. This one is actually break into a circular shape, so it will become a heart actually. But you see it's x to the 2 third plus square root r squared plus x squared. That's actually a circle graph. So this is interesting. This can make a heart small, big. It's actually pretty interesting. So yeah, it's actually pretty impressive. She went out with him at homecoming or something. I don't know. Very cool. Anyway, so vertical tangent. So vertical tangent and cusp. In this case, it happened at the same time because it looks like this. X to the 2 third power is going to look like this. And that's the cusp. Any other questions? Yes. Exactly, because I have a drastic change of slope. It went from -1 to +1. Right? If you have that, it doesn't work. And I like that because I think Alejandra yesterday picked up a question. I think that one over there, she did it that one. She did a phenomenal job. She did it from both sides, and she figured out it's not differentiable. That's a very good example. If I have time, I will go over that question. But you can more welcome to take a picture of that question. It's very good that she did it from both ends. Cusp.
Yeah, the other one, the black arrow.
Even over odd power. So you have even over odd power, you're gonna have that. Now what's a vertical tangent look like? The vertical tangent looks like this. This is the vertical tangent look like x to the 1/3. 1/3. Do you see that this is called vertical tangent? Do you look at the slope here? It's completely straight. That's also not differentiable. This is also not differentiable. And I think about, like, think about car like going straight up. It's kind of scary. But this can happen because I don't think the car have enough momentum to go like straight up like this. I think it's really hard to build enough momentum unless that is really deep. But I guess you could, because you can also have a loop of roller coaster. That's actually a vertical tangent on the right hand side, on the left hand side. That can happen on roller coaster. So vertical tangent is the only situation that doesn't really make sense as far as analogy goes. So that's a vertical tangent. You're gonna be like, well, what was it look like if I were to take a differentiable, the derivative of this function? So I'm gonna show you the derivative of absolute value. So let's just say f of x equal to x minus 2. And it will say, hey, limits as x approach to 2 from the left. Well, 2 from the left, which equation I'll be using? If I use f prime of 2, I'm going to use definition of the alternative derivative. So that's going to be negative x minus 2. Is that okay? Because I coming from the left side, I use a negative version of that equation over x minus 2, because I'm going to use definition alternative derivative. This will plug in, that's going to give me negative 1. Now I can do it from the other side, limits x approach 2 from the right. Then I'm going to use the positive version of that, which is that's what Daniela did with a different question. That's 1. So f prime of 2 does not exist, because it technically is like this. So anytime you have a drastic change of slope, it does not exist on a particular point. This is not differentiable. But this one's m is equal to 1. This one's m equal to negative 1. So yeah, if you have change of slope, that does not differentiable. Is that okay? Now let's just show you x to the 1/3. Again, we're using this. We use the definition alternative derivative to figure out at 1. So what if I have f of x equal to 1/3 and that c is equal to 0? What will happen? Limits as x approach 0, f prime of 0. What's f of x in this case? X to the 1/3, right? It's okay. What's f of c? What's the c in this case? 0. So if I plug in, it'll be 0, right? And then x minus c, right? Now what will happen? It'll be limits as x approach 0, x to the 1 over x to the 2/3, because I simplify it. What happened when they reach 0? Do you guys know? What happened when x reached 0 in this situation? Well, first of all is 1 over 0. So we plug in what? 0.1. Does that make sense? So square root 0.1 to the 0.1 to the 2 over third power. It doesn't matter. It's going to go to very small. If it go to small, then the top is 1, so it's going to infinite. Does that make sense? So that's where the vertical tangent is. Vertical tangent. Because the slope equal to infinity. And limits as x approach 0 from the negative side, it's still going to be 0, 1 to 2/3, and it's still going to be past infinity. That's still a vertical tangent, still does not exist. So f prime of 0 does not exist because it reached infinity. Infinity in this case, we're going to say does not exist. It's not differentiable. So a vertical tangent can be represents that. So you can have two situations. You can do it with a cusp as well, x to the 2 to the power. And you're going to get a cusp. So that's that. We are moving forward. We're going to take a derivative of a constant. What did we talk about yesterday? If I take a derivative of a c, what is that equal to?
0.
Why is 0 again? Because a bit says it's a horizontal line. And a horizontal line, you have a slope of 0. So therefore, derivative respect to x on c is equal to 0. This is called constant rule. Derivative of any number is 0. Derivative pi is what? Derivative e is what? They're all numbers. Right. We also take a derivative of x to the n yesterday. We say what's derivative of x to the n? This n is going to be drop in the front, and then it's going to be subtract 1. So it'll be n x to the n minus 1. Do you guys remember that? N in the front, x to the n minus 1. Now, you have to make sure this have to be on numerator. What does that mean? It doesn't work with 1 over x squared. This one, it does not follow the rules because 1 over x squared is not on the numerator. Can I take a derivative 1 over x squared? Yes, but you have to do some other thing first, right? So if I want to say take a derivative of this, in current stage, you cannot use power rule because the power rule did not say 1 over x to the n. The power rule says, hey, this doesn't work right now. We got to change to where the position that will work.
X to the power of -2.
Yes. So Ian says it's x power to -2. Now I move to the numerator. Now I can apply a power rule. I like Ian sitting here. I should have arranged Ian sitting here all the time last year. Instead, throw a marker across the room. Now I can beat him with a textbook.
I'm gonna do that answer there. That's where the strongest skill is, but also where the most interest.
Okay. Okay, so now I'm going to take a derivative of this part now. So, derivative of this part, remember, this fall into the front. But don't forget that -2 is going to be what? Subtract 1. Does that make sense? So it'd be -2 x to the 93. That's equal to -2 over x cubed. This is the final answer. Now, this can be a final answer, but I like this version better because you can change your positive exponent. You know what to do over there. But that's also known as the negative exponent rule. So a to the -n equal to 1 over a to the n, or 1 over a to the -n equal to a to the n over 1. So, so that's why your algebra skill is so important. If you don't have algebra skill, it's very hard to survive calculus. Let me ask you, what's the derivative of 4x? Now, there's two ways to look at this. What's the derivative of 4x? I know a bit, no. Andrew also know because Anthony told him already. What do you think derivative of 4x is?
0.
Nope. Lucas?
Over x.
No.
Okay, so to start off with, it has a starting exponent of 1.
Marshall? It's a 4. Why is it 4 though? Think about it. Why go to 4x?
Because you haven't.
Slope is what? What is slope? Slope is 1, right? So technically, this is 1, right? Can I drop to the front? Says 4 times 1, x to the 0.
That's it.
What's x to the 0?
1.
1. So 4 times 1 times 1 is equal to 4. Or you can just say, oh yeah, the slope 4x is just 4. Done. I don't have to do any more thing because y go to mx plus b, right? So that's gonna derivative of 4x is just 4. Okay, so that's ask you to take a derivative of this. I'm gonna do it a long way on a just for fun on the bottom and just show you the comparison. Right, long way is gonna be like this. You don't have to copy this down because you should know how to do that by tomorrow because you have definition of derivative for tomorrow quiz. But this is how long it's supposed to be. I gotta multiply by conjugate. See how much work is this? Too much? But you have a quiz tomorrow about this. What happened is this gonna cross it out. That's a -1. So actually a square of 0 is mean -1. Square root x times square root x times by this is, oh sorry, this one is plus. This is a plus. So it'd be square root of x plus square root x. So it'd be -1 over x times 2 root x. -1 over 2 x root x, right? Look at how much work is this. This is tomorrow's quiz. Look at how much work is this. I suppose let's take a derivative of this. Did you guys change to the -1/2 power?
Yes.
And -1/2 x to the -1/2. Is that true?
Yeah.
Oh, -3/2. I didn't make a mistake. Is that true?
Yes.
So that's -1 over 2. X to the 3 over 2. -1 2 x square root third.
Yeah.
-1 over 2 x root x. Do you see this answer? So much better compared to this amount of work. However, you had to do that tomorrow because you need to know how to do algebra in order to survive my class. It's not because I like to make fun of you. Says, hey, there was an easy way, but you cannot use it. You can use it after tomorrow's quiz. Which way you prefer? Second way, okay.
No.
Okay. No, I don't have enough life for that. I'm not grading that. I only going to grade it one time, and I don't want to grade it again. Do you see how easy this is? Power rule, right? Now, I'm going to talk about constant multiple rule. If I take a derivative of a c of f of x. Now, here's the thing. C doesn't matter. They can be outside. You already did that. And that's equal to c of f prime of x. That's how I take a derivative. I take a constant now. I ignore them. I multiply at the end. Multiply, not add. Okay? So that's ask you to take a derivative of this one. I'm gonna say y equal to 1 over 2 root third x squared. So I want you to take a derivative of this. Make sure you rewrite them, move the constant outside before you take a derivative. But yeah, you can take a derivative of this very easily. Wait, what time I get off here?
Get out of this class at 9:06. Yeah, I misheard you.
Did you do that? That's just I haven't taken a derivative yet. I rewrite to the top. I'm gonna take a derivative. That constant, just leave it in the front. Don't worry about it. Negative 2 third x to the negative what? What? 5 over 3. So that's gonna be negative 1 third x to the negative 5 third. Is that okay? And negative 1 over 3. You can do x to the 5 over 3, which is also negative 1 3 third root of x squared x. I mean, that's probably the best answer here. But this one is fun. If you get to hear, it's fun too. Actually, you get to hear, it's fun. Is this okay? Now I want you to take a derivative of 5 different functions. 5 over 2x to the cube. And make sure the things that is going to kill you is your algebra skill.
That first one of x to the power 2.
3. So I want you to take a derivative of all 5 functions here.
Oh. Wait, all 5 functions?
Or 4. Sorry, I can't count.
It's the way it is.
So 7. 2x power third.
It's third. Last one is 7, yeah. I always first step I rewrite x to the numerator. Did you guys do that?
Mm-hmm.
So if I rewrite this, would it be 5 over 2 what? X to which power? Negative 3. I just use negative exponential rule. Now I take a derivative. So now I take a derivative. Don't get used to that. I haven't taken a derivative yet. I just rewrite them. 5 over 2, negative 3 x to the negative 4, right? So it'd be negative 15 to x to the 4. And that's your final answer because you take a derivative and then you move to the bottom. The problem is people make simple mistakes. Even though it looks really easy, people still make a lot of simple mistakes. Now for this one, I rewrite them, but if I rewrite them, you have to pay attention to the exponent rule. 2 is also to the third power. X is also to the third power. So let love with what? 8x to the third. So it looks like the same problem. They're not same because the parenthesis is changed. So that is equal to 5 over 8x to the negative 3. You move to the top. Y prime is equal to negative 15 over 8x to the negative 4. Or negative 15 over 8x to the 4th. Does that make sense? It's not hard. It's just understand. Now, this one is interesting. X to the negative 2. It's on the bottom. So what do I do?
Does it become positive if you double negative it?
Yeah, so it'll be x to the 2 on the top. You're a genius. Y prime is equal to 7 over 3 times 2. That x to the first, so it'll be 14 over 3x. And you're done. Last one. 7 over 3 to the negative 2, x to the negative 2. That means everything flipped to the top. That means 63x squared. And take a derivative. It's going to be 126x to the 1. Now, sometimes I want to talk about 2 things before you leave. Sometimes like this, you want to expand them. So that's equal to 4x squared plus 4x plus 1. And the y prime is equal to 8x plus 4. Is that okay? Super easy. Sorry, sometimes you can have this. Square root x plus 1 to the square over square root x. Now, make sure you do algebra first. What can I do with algebra? I can expand the top. So it'll be x plus 2 root x plus 1 over square root x. Now pay attention. This is a question I love to test a lot because I can rewrite this to like this. I can say x to the 1/2. I can split them, and now I can take a derivative individually. So 1/2 x to the negative 1/2. And take a derivative 2 is 0. And this is negative 1/2 x to the negative 3 over 2. I'm so sorry I extend a little bit longer. But I just want to make sure that you do the last part. Split them all up, expand them, split them, and then take a derivative. Yeah, it's not hard.
Just having a practical example of actual numbers and having more than one of them really helps. So you like see how the numbers go through it. Just looking at stuff in practice.
By sitting here, I think it'll be better because I can smack you with a textbook anytime. Whack!
I don't care what happens as long as I can get it done.
Okay, just kidding. I won't whack you. But if it's necessary, then I can watch you here a little bit better more than the other side.
I am trying.
I know.